In this video, I'll show you how to use n8n and the Home Assistant MCP Server to create an automation where a Google task in your to-do list, created with your voice or by typing, triggers an AI to control your smart home. Alright, first things first, let's set up the bridge that makes this all possible. Over in Home Assistant, go to your Devices and Services, click Add Integration, and search for MCP. Now, this is critical. You'll see two options. You need to install the MCP server, not the client. The server is what allows n8n's MCP client to connect and give commands. Don't get them mixed up. With our server ready, let's jump into n8n and start building the workflow. The first node is our entry point, the schedule trigger. Its only job is to automatically start the entire workflow at a regular interval. In its configuration, we set the trigger interval to minutes and the minutes between triggers to 5. In this project, we need a system that is constantly checking our Google Tasks list for new commands. By checking every 5 minutes, we strike a good balance. It's responsive enough that your command will be executed within a few minutes, but not so frequent that it's checking unnecessarily. Okay, so our trigger is set to run every 5 minutes. The next step in the real-world process is for you to create a Google task. You can do this right on your phone using the Gemini app, either with your voice or by typing. However, for the purpose of this demonstration, you'll see I have this node here in n8n, Create a Task. In its configuration, we've simply chosen our task list, and in the title field, we've typed in our keyword, sleep. Think of this node as a convenient placeholder, a testing tool that we'll remove once we're confident everything else is working perfectly. So whether the task was created by our test node or by you on your phone, the next step is to actually check for it. This is handled by another Google Tasks node, Get Many Tasks. Its purpose is to connect to your Google Tasks account and retrieve a list of all the tasks from a specific to-do list. The configuration is simple. Operation is get all, we choose our task list, and we make sure return all is enabled. Now, it's very important to understand that this node retrieves every single task from your list, including tasks that are already marked as completed. This is a potential problem because we definitely don't want to be processing commands that have already been executed. This raw, unfiltered list is now ready for the crucial filtering step. This brings us to the if node. This is our command validator. It looks at every single task and asks two important questions to decide if it's a valid active command. The configuration has two conditions that both must be true. First, the title must contain our keyword, sleep. This finds any task that is meant to be a command. The second and equally important condition checks the status. We set this to check if the status is equal to the string needs action. This second rule is our safety check. It ensures we are only processing tasks that are new and uncompleted, filtering out any sleep tasks we've already run. So the combined rule is this a task that contains the word sleep, and is it a task that still needs action? Only a task that meets both conditions will pass through the true exit. The if node has now identified our command. It passes this valid sleep task to the brain of our operation, the AI agent. Its job is to receive the trigger signal and then use natural language to execute a specific action. Its core configuration is a collaboration of three key parts. First is the system message in the prompt. This is the critical instruction where we tell the AI, you are an advanced home automation assistant. You must use the Home Assistant MCP tool to perform any actions. This forces the AI to actually use the tool we provide. Next is the prompt itself. Since our if node has already confirmed the intent, we give the AI a direct command, turn off bedroom light. Then we attach the two components that give the AI its power, the DeepSeek chat model as its brain, and the MCP client tool. Now let's look closer at the MCP client node's setup, because this gives the AI the ability to control Home Assistant. Its configuration is crucial. First, in the endpoint URL, enter the exact address of your Home Assistant's MCP Server API. Next, under Authentication, select Header Off. And finally, in the Credentials section, create a new credential, Add a header named Authorization, and the value will be bearer followed by your Home Assistant long-lived access token. By configuring this tool correctly, you are giving the AI a secure, direct line to Home Assistant. So, the process is simple. The if node says go. The AI agent reads its mission, turn off the bedroom light, and uses the fully configured MCP client tool to send that exact command to Home Assistant. Our AI agent has just successfully sent the command. The original sleep task has now served its purpose. This brings us to the final and very important cleanup step, the update a task node. Its job is to modify an existing task. In its configuration, the operation is update. The crucial part is the task ID. We use an expression to pull in the unique ID of the sleep task that was found by our Get Many Tasks node. Finally, under Update Fields, we set the status to Completed. This step is vital. It prevents our automation from getting stuck in an infinite loop, ensuring every command is only executed once. And that's our workflow. Now, every night, a simple sleep task created by voice or text becomes the command to automatically shut down your devices for a worry-free end to your day. By the way, I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Every like and subscribe truly helps the channel expand. Thanks for watching.